this lesson is on exponential and logarithmic functions. Exponentials and logs are inverses of each other. So they have similar characteristics in opposite fashion. So exponential and logs are inverses. An exponential function has the form y equals a times b to the x power. So the key thing is that x is in the exponent. That makes it exponential, if x is in the exponent. So the domain of an exponential is always negative infinity to infinity. And the range for just the normal exponential function is 0 to infinity, but that could change depending on the shifts, up or down, left or right. The common point is 0 to 1, and there's a horizontal asymptote, so that's a line that it doesn't cross through at y equals 0. So right here is an example of an exponential function right here. So as you can see, the domain is negative infinity to infinity. The range goes from 0, because it never crosses 0, to infinity. It goes through 0, 1, and the asymptote, a line that it never crosses, is at y equals 0. Now, just like we learned yesterday, if you add a number to the outside, it makes it go up. If you subtract a number on the outside, it makes it go down. If you add a number on the inside, it makes it go left. And if you subtract a number on the inside, it makes it go right. So inside is opposite of what you would think. So the domain, after you transform it, is still negative infinity to infinity. The domain of an exponential will always be negative infinity to infinity. But the range changes. So whatever number you're adding or subtracting becomes your new range. So let's do an example. So they've already graphed this. So this was the original exponential function. And what they did, now we need to shift it up 2 and left 1. So you start at 0, 1 today. Start here, and you go left 1, up 2. And then you draw your curve. So this asymptote will shift up 2. So let's do the domain, and we're going to do of the blue one. So the domain is negative infinity to infinity. It goes left and right forever. And the range is now 2 to infinity because it goes up 2. So your asymptote moved to 2 to infinity. All right, over here you have your original 1/2 to the x. This one's a decay, so it's going down. And it goes, the transformations are down 1 and right 2. So start at your point right here, 0, 1, and go down 1, right 2, and then draw your new curve. All right, so of the red, your domain is always negative infinity to infinity, but your range on this one is negative 1 to infinity. So your range is always that number. Okay. All right, so the next function we're doing today is logs. That is y equals log b. Oops, I'm sorry. All All right, so log base b of x. Okay, so you'll notice that these are switched right here. The domain of a log is 0 to infinity of the original, and its range is negative infinity to infinity. So those are opposite of the exponential. The common point is 1, 0 instead of being 0, 1. And this one has a vertical asymptote at x equals 0 instead of y equals. All right, so look at this black function over here on the graph. As you can see, the domain is 0 to infinity, left to right. The range is negative infinity to infinity. And it goes through 1, 0 is the common point. And it has a vertical asymptote at x equals 0. All right, same things. If you're adding d on the outside, it goes up. If you're subtracting d, it goes down. If the number on the inside, if you're adding, makes it go left. If you're on the inside and you're subtracting, it makes it go right. All right, the domain after you transform it will be c to infinity, and the range will always be negative infinity to infinity. Okay, let's do these two examples. So they've already graphed this one for you. It's in black. And now we have to do some transformations. So the minus 3 makes it go down 3. And the plus 1 makes it go left 1. So start at your point right here, 1, 0, and go left 1, down 3. And you're going to draw a new curve. And we need to give the domain and range of the green one. Feel free to pause this video at any time and rewind it if you miss something or if you want to hear it repeated. So the domain for this one, this asymptote has now shifted left 1. Shifted left 1. So your domain is negative 1 to infinity. And your range will always be negative infinity to infinity for a log function. Okay, let's go over here to this one. They've already graphed this top one, and now we have to move it right to and up to. So start at your point 1, 0, and go right to and up to, and draw a new function. Your asymptote will have shifted right to, and so your domain is positive 2 to infinity, and your range stays the same, negative infinity to infinity. All right, so now we have some examples. You can definitely use the top half of this sheet to help you fill these in. You can also use your calculator to help you, because that's a lot of things to memorize. So on the calculator, if you wanted to have some help, you would go to y equals on your calculator. So the y equals button's on the top left, and clear out anything that's in there. All right, so I'm going to type in 4 to the x minus 3 plus 5. Type it in exactly like you see it, and then I'm going to hit graph. All right, so the calculator will help you with the domain and range. So your domain on this one is going to the left forever and the right forever. So that is negative infinity to infinity. If you look up at the top of your notes, you also know that if x is in the exponent, then it will always have a domain of negative infinity to infinity. But the calculator will help you if you don't memorize that. All right, if you look at the calculator again, the range is +5 to infinity. It also has an asymptote, a line that it never crosses at y equals 5. So y equals makes it a horizontal line. Okay. All right, so this next one, if you wanted to use your calculator, all right, so you go to y equals, clear out what's in there. For this one, you'd have to hit the math button and scroll down to A. And so you're going to type in log base 3 of x plus 4 minus 3. Hit graph. So as you can see, the domain from left to right is -4 to infinity. And the range is kind of hard to see on the calculator because they don't have arrows, but it does go down forever. So there should be an arrow pointing down right here. You just have to know that. The range of a log function, so if you see the word log, the range will always be -infinity to infinity. Okay. All right, this one, if you look at the calculator again, has an asymptote at x equals -4. It never goes past that imaginary line. All right, the next one, is this an exponential or log? All right, it's an exponential. So you automatically know your domain is going to be -infinity to infinity. And when you look in the calculator, when you type it in, you can see that 1/3 to the x plus 5 minus 2. You can find out where your asymptote is. All right, so it's never going below -2, and that's y equals -2. So y equals -2, and it goes -2 to infinity. As you can see, this number matches that on exponentials. Okay. And this number, you got to do the opposite because this inside matches that one. Okay. All right, this last one is a log. So the range is going to be -infinity to infinity. You can put it in your calculator, hit the math button, and the domain is going to be 4 to infinity, and it's x equals 4. So you can see the pattern there. All right. All right, before we do rules of logs, which is a review from last year, let's review rational exponents. So for this, it's power over root. So you can rewrite this without the root symbol, and you can rewrite it as a fraction. The power is 2 over the root of 3. So that's another way to write that, x equals 2/3. For this one, your power is 1 and your root is 5, so it's x to the 1 over 5. For this one, there's two imaginary numbers. There's a 1 and a 2, so x to the 1/2. For this one, you've got to do two separate letters, so x to the 1/3 and y to the 1/3. And this last one, there's a 2 if there's no number on the outside, so it's x to the 4 over 2, which is the same thing as x squared. So the root is the number on the outside. Think about roots of a tree or outside. And the power is the number on the inside. And you make it a fraction. Okay, so for logs, If it is asking you to condense, that means to put something together. So here we're going to put these two logs together. And addition turns into multiplication. So again, you did this last year. So 5 and x is just 5x. So here's another one. We're putting log 4 plus log 6 together, but you don't add them. You actually multiply 4 times 6, which is 24. This one you're putting log base 2 of x and log base 2 of z together. So it stays log base 2. You never change this bottom number. That never changes. But you're going to multiply x and z, so it's just x, z. All right, expand means to make something bigger. So we're going to turn this into 3 logs. So right now they're being multiplied, so multiplication turns back into addition. So log x plus log y plus log z. All right, for this one, we're going to turn it into 3 logs because there's 3 things. So log base 3 of 2. Multiplication turns into addition. Log base 3 again. The bottom base never changes of m plus log base 3 of n. All right, feel free to go back and rewind that if you need me to say it again. Should be a review from last year. All right, now we're still condensing right here. But subtraction turns into division. All right, subtraction turns into division. So it's going to be, condense means to put it into a single log, and it's going to be x divided by 3. So again, we have subtraction that turns into division. So you just write log, and then it's 7 divided by x. So go in the order they give it to you. This one would be log base 5 of y divided by 8. And this one would be log base 2 of 10 divided by 2, which is the same thing of log base 2 of 5. Okay, over here we are expanding, which means to have more than one log to make it bigger. So log of x, division turns back into subtraction, log of y is how that one works. This one, log base 7 of 9, division turns into subtraction, so log base 7 of x. All right, and the power property. So we are going to condense, which means to make it smaller. What you can do with logs is whatever's in front becomes its power. So log y of 3, kind of did this in the first unit a little bit. And here the x would go up with the 5, so log base 5 of x. And this one, the 1/3 would go up with the x. Another way to write this one is what I was kind of talking about at the beginning, was the cube root of x to the first would be another way you might see it on a multiple choice test. Okay, for this one, expand. We want to make it bigger, so the way we do that is we take the 3 and we throw it back in front. So 3 log x. Here we take the 2 and throw it in front. 2 log base 5 of x. For this one, you're going to have to change this into an exponent. So it's log base x of 1 divided by 2. And then we're going to throw that out front. So 1/2 log x. All right, last 4 examples. So we are condensing. So that means putting it into 1 log. So I just write the word log. Plus means I'm going to multiply these. So x times y. And then subtraction turns into division, and I have to divide by z. All right, for this one, the 2 goes up with the x, so it's x squared, so log of x squared. Subtraction means I'm going to divide, and the 3 goes with the y, so I'm dividing by y to the 3rd. Plus means to multiply, and the 4 goes with the z, z to the 4th. So that's your answer. Okay. All right, and the last one, expand to more than 1 log. So log of x times, that turns into plus, log of y, but this 2 needs to go out front. So I'm going to squeeze it in right there. 2 log y. Division turns into subtraction, log z. All right, here you are multiplying. So log 3, multiply turns into addition, plus log. We need to change this to x to the 1/2 and y to the 1/2. So the 1/2 is going to go in front. So I'm going to squeeze in a 1/2 here, x. And this is more multiplication, so I'll put a plus log y, but it also needs a 1/2 in front. So your answer is log 3 plus 1/2 log x plus 1/2 log y. All right, again, go back and rewatch any part of this video that you didn't understand, and it will help you to hear it again.